We're now moving on into multiple regression. All multiple regression means is that you have more than one predictor in your model. That's it. Now, that's going to mean something for how we write our RStudio code, and it's also going to mean something for the interpretation of the slope coefficients when we get there. But let's go ahead and jump on in and talk about how we make RStudio code do multiple regression. So like I said, when a model is using more than one predictor, we separate them inside the lm command with plus sign. So here's your usual command, model equals to lm y tilde. But notice my predictors separated with a plus sign. Now it says x1, x2, x3, but those could be, area or age or salary. Who knows what those things could be. But each of those predictors are separated with a plus sign. That's it. Now, like I said, this also has implications for the interpretation of the slope coefficient. The template looks like it did before when we did for simple linear regression with one predictor. When the predictor increases by one, we predict that the y variable to increase by whatever the slope value is. Now, we won't say increase if the slope is negative. We'll say decrease by that slope value, but that's not the most important part. The most important part is this new little bolded and italicized phrase here, while holding all other variables constant. This must be said as part of the interpretation. Otherwise, that answer is wrong. You're going to see many different interpretations of slope coefficients, and some of those are going to be missing this statement, or they're going to have some warped version of it, which is not correct. So you got to keep an eye out for this. Put a star next to it. It's really important. It messes. That's a star, believe it or not. This messes people up all the time because some interpretations look good, but they're missing this bolded and italicized statement. Interpreting the intercept. The template here doesn't need to change. It's the same as it always was, except instead of talking about one predictor, you're talking about all the predictors. So when each of the predictors takes on a value of 0, then the corresponding y value is whatever the intercept is. Now, sometimes this doesn't make sense. We've talked about situations where we're trying to predict salary from age. So, it doesn't really make sense to talk about the salary of somebody who is 0 years old. We don't really have jobs for newborns. So for that reason, you got to be careful about making sure you interpret those intercepts appropriately. Sometimes it'll say something like, well, maybe it doesn't make sense to do that, in which case, yeah, it depends on the situation. So let's jump on to an example. Suppose we want to predict a student's GPA from the SAT math score and their SAT verbal score. There's a model we would make. There's GPA based on quantitative. That's the Q stands for quantitative, but that's the math score. And SAT-V for SAT verbal. All right. The summary output shows this little table here, and now we can answer some questions. True or false? When SATQ increases by 1, we predict GPA to increase by 0.0017. Now that looks good. I mean, when I look at the SATQ variable and look at the associated slope coefficient, I see 0.0017. But as I just got finished saying, you need to have something like this at the end or somewhere stated in that interpretation while holding all other variables constant. And because no such thing is present in this first statement, it's got to be false. How would it be made true? It's probably the next question you're asking. What would that have needed to say in order to be true? It would have needed to say something like, for a fixed value of SAT verbal, or while holding SAT verbal constant, something like that. If a student's SAT math score and SAT verbal scores could somehow be 0, their predicted GPA would be 1.456. I'm very comfortable calling this true for a couple reasons. One is, I see the intercept value is indeed 1.456. I've just rounded it. We are talking about an intercept here because we're talking about the predictors being a value of 0. My other hesitation would normally be, well, is it even possible for your verbal score or math score to be 0? I think on the SAT, your lowest possible verbal and math scores are 0, or not 0, but 200. So why would I then say this is true? Well, this is because of the big word if that they put at the beginning of this sentence. They said, if it were possible. Yeah, we know that SAT verbal and SAT math scores can't be 0, but if it were possible, what would the model then say about their predicted GPA? So this big word if here makes me much, much more comfortable saying true. If it had just said when math and verbal scores are 0, their predicted GPA would be this, I'd start to hesitate because I'm like, well, is it even possible for those scores to be 0? But this big word if makes me feel a lot safer saying that this is true. When SAT verbal increases by 1, we predict GPA to increase by 0.0013. Well, there's my verbal, there's my corresponding slope coefficient, but it says regardless of SATQ. It looks like that little piece of information that I said needs to be at the end of the sentence or stated something about the other variable, but it's not regardless of SATQ. You need to say for some fixed value of SATQ or for while holding SATQ constant, which doesn't say. This says regardless of SATQ, and that's what makes it false. Last one. For a fixed value of SATV, there's what we're looking for. This guy is what I've been missing all along. For a fixed value of SATV, GPA is predicted to increase by 0.0017 for every 1 point increase in SAT math. That is true. We finally have a correct interpretation of the slope coefficient with this correct number here, but then we made sure to say something like while holding SAT verbal constant. Let's do another example where we're actually going to dive into some RStudio. So this question says, for using the houses data set, build model 2 predicting price from living area and age. I'm going to jump into RStudio. I've got my houses data set imported. I'm even going to click the arrow next to houses just to make sure I'm seeing the seeing all the predictors that I'm going to be using. Model 2 says predict price from living area and age. So I'm going to say model 2 equals LM, open parentheses. I'm predicting price. There it is over here, price from a living area, which by the way is stylized with a, take note here, a capital A, living area, capital A, and age. Make sure we cite our data set, data equals houses. And our model is now made. One of the first things I do when I make a model, just because I know I'm going to be answering some questions about it, is summary of that model and content of that model. Those are just the things that I almost automatically run whenever I make the model because I bet you're going to ask me about it. And sure enough, that's what this guy's doing. We want to know when the age of a home increases by 1, price decreases by approximately 225. Let's go look at that slope coefficient. Scroll up here. When the age of a home increases by 1, we seem to see that the price decreases by about 224, which rounds to $225. Again, seems like a true statement. Seems like it's reasonable. But what's missing? It's missing that additional statement while holding square footage constant, and it didn't do that. We did not see that in this statement. So for that reason, I have to say, well, this is going to be annoying to have to hold this. I have to say this is false. Okay. For homes of the same age, there's this phrase that I'm looking for. For homes of the same age, this is a good start. Each additional square foot has an associated price increase of $111.23 $28. Let's go have a look. I see 11128. Yeah, we're close. Yeah, it's actually rounds to that. So I'm pretty happy with that. I think I like my answer, and this is true. Let's do this in green. A green check mark. Green for go. Sorry, I can't grab my marker. Check. Put a true here. True. After controlling for age, I love seeing it. After controlling for age, a $1 increase in price leads to a 108.2 increase in living area. It looks like this would be true because I've got that little piece stated correctly, but this says a $1 increase in price. That's not what we usually do. We're trying to predict price. So this is false because what they've done is they've mixed the order around. We're not trying to predict the living area of the home based on its price. We're trying to predict the price of a home based on its living area. So this is false because they've got the interpretation backwards. They do have the after controlling for age, which I like, but I don't want your brain to start thinking, oh, the moment I see that, I know it's right. You got to make sure the rest of it's right. It's more that a one square foot increase in the size of a home leads to an associated price increase of 111. So both pieces have to be right. You can't just have the after controlling for age part correct. Okay, next two. When accounting for the area of the house, the model suggests a statistically significant price difference for each year older the house is. Let's go look at our confidence intervals, because that's how we ascertain statistical significance. When accounting for area, okay, so that's controlling for area, that's good. And it says, looking at the age coefficient, we want to suggest looking for a statistically significant price difference for the age of the home. Well, let's look at the age confidence interval. There it is down below. I see that it does not capture 0, so I'm inclined to say this is true. Let's get my green marker out. I'm inclined to say this is true. Okay. The model suggests, this last one, the model suggests that let's get rid of this letter A. The model suggests that increasing the area of the house has a statistically significant impact on price no matter how old the house is. This is false. Why? Because they said no matter how old the house is. This needed to say for a fixed age, or while controlling for age, or something like that. But this says no matter how old the house is. This is remember the word regardless back in the previous over here? This was made false because it's used the word regardless. Well, guess what? That's what this is saying. It's saying regardless of the age of the house. So this is also false. I feel like I spent a good, this is almost 10-minute video now, but we talked quite a bit about what's important when it comes to making sure our interpretations are correct. We got to make sure that we're saying while controlling for all other variables when we're doing that slope coefficient interpretation. Obviously, all the other things that we know about, making sure we correctly interpret the slope of a predictor based on it's a 1-point increase in that predictor leads to a slope value increase in the response variable, but we also have to make sure that additional piece of information is included in that interpretation. Thanks for watching. My name is Andy, and if you found that video useful, we've got plenty more videos just like it. We're giving away a free month of membership, our essential membership to GPA Factory, a free month of it. If you want to get it, just go to this URL and use code YouTube100 to start learning from one of the best to ever teach it. That's me. See you guys soon.